This video is about sinusoidal graphs. These are graphs that could be modeled by either a sine function or a cosine function. This is AP Precalculus topic 3.4 and 3.5. If you appreciate this content, please give it a like. Number 1. The sinusoidal function f of x is shown in the figure above. Find the period, frequency, amplitude, and midline for the graph of f of x. The period of a function is the horizontal length of one cycle, which can easily be measured from peak to peak. From -2 to +2, the period is 4. The frequency is the reciprocal of the period, so in this case it is 1/4. The midline is the horizontal line halfway between the highest value and the lowest value. In this case, it's pretty easy to tell that the midline is y equals 1. A horizontal line is always y equals something, in this case y equals 1. You can also find the equation of the midline by taking the average of the highest value and the lowest value. So you could do 3 plus -1 divided by 2. But that's really 3 minus 1, which is 2 divided by 2, so y equals 1. The amplitude is the distance between the midline and the highest value, or it's the distance between the midline and the lowest value. Either way, the amplitude is always positive, and in this case, the amplitude is 2. Number 2. The sinusoidal function g of theta is shown in the figure above. Find the period, frequency, amplitude, and midline for the graph of g at theta. The period is the horizontal length of one cycle of the function. This cycle goes from 0 to pi/2, so the period is pi/2. The frequency is the reciprocal of the period, so if you flip this upside down, you get a frequency of 2/pi. The midline is the horizontal line halfway between the highest value and the lowest value. The midline in this case is y equals 1. Don't forget the y equals. I'll remind you that you can also calculate the equation of the midline by taking the average of the highest value and the lowest value. In this case, 4 plus -2 divided by 2. This is 4 minus 2, which is 2, divided by 2, gives you y equals 1. The amplitude is the distance from the midline to the highest value. The amplitude is always positive, and in this case the amplitude is 3. Let's find the same four values for h of theta in number 3. Here is one cycle of the function, which stretches from 0 to pi, so the period is pi. The frequency is the reciprocal of the period, so 1/pi. The midline is the horizontal line halfway between the highest value and the lowest value. It's pretty easy to see that the midline is y equals -2. You can also calculate the midline by taking the average of the highest value and the lowest value. In this case, that would be 1 plus -5 divided by 2. That's 1 minus 5, which is -4, divided by 2, and that gives us y equals -2. The amplitude is the distance from the midline to the highest value. In this case, the amplitude is 3. The amplitude is always positive. For the next few problems, we are given some information about the function, but we are not being given the graph. Number 4. The sinusoidal function g of theta has a maximum at the point 0, 24. The first minimum after reaching this maximum value occurs at the point 3 pi, 10. Find the period, frequency, amplitude, and midline for the graph of g of theta. Quick side lesson using the graph from number 2. Notice that the period of this function is 4 spaces across. Now notice that the horizontal distance between consecutive maximum value and minimum value is 2 spaces. That's half the period. This will always be true. The horizontal distance between consecutive max and min is always half the period. For this function, the input values are values of theta. So the horizontal distance between the max and min is given by theta max minus theta min. Since the horizontal distance between max and min is half the period, then the period will always equal double the horizontal distance. By the way, the horizontal distance between consecutive max and min could be theta min minus theta max. It's always the second one minus the first one. Technically, if you put an absolute value on it, the order won't matter. For number 4, the horizontal distance between consecutive max and min will be given by 3 pi minus 0. This is half the period, so if we double it, then we have an expression for the period. 3 pi minus 0 is just 3 pi. So this is really just 2 times 3 pi, and the period is 6 pi. The frequency is the reciprocal of the period, which will be 1 over 6 pi. Without a graph, the easiest way to calculate the equation of the midline is to take the average of the highest value and the lowest value. The midline will be given by y equals 24 plus 10 over 2. That's 34 over 2, which is equal to 17. So y equals 17 is the midline. Don't forget the y equals in the front. The amplitude is the distance from the midline to the highest value. In other words, the amplitude will be the highest value minus the midline. In this case, the amplitude is 7. Number 5. The sinusoidal function h of theta has a minimum at the point pi over 4, 6. The first maximum after reaching this minimum value occurs at the point 5 pi over 4, 16. Find the period, frequency, amplitude, and midline for the graph of h of theta. The horizontal distance between consecutive max and min will be given by 5 pi over 4 minus pi over 4. But this is half the period. So if we double it, now we have the value of the period. 5 pi over 4 minus 1 pi over 4 is 4 pi over 4, which is simply pi. So we have 2 pi, and that's the period. The reciprocal of the period gives the frequency, which is 1 over 2 pi. The midline will be y equals the average of the highest value and the lowest value. So y equals 16 plus 6 divided by 2. But that's y equals 22 divided by 2, which is y equals 11. That's the midline. The amplitude is the distance from the midline to the highest value. In other words, the amplitude will be the highest value minus the midline. In this case, the amplitude is 5. Number 6. The sinusoidal function k of theta has a minimum at the point negative pi over 2, negative 4. The first maximum after reaching this minimum value occurs at the point 0, 8. Find the period, frequency, amplitude, and midline for the graph of k of theta. The horizontal distance between consecutive max and min will be given by 0 minus negative pi over 2. This is the same as 0 plus pi over 2, or simply pi over 2. But this is half the period, so if we double it, then we have an expression for the period. So the period is 2 times pi over 2. The 2's cancel out, and the period is simply pi. The frequency will be the reciprocal of the period, so the frequency is 1 over pi. The midline will be y equals the average of the high and the low value. So that's 8 plus negative 4 divided by 2. 8 minus 4 is 4, and 4 divided by 2 is 2. So the midline is y equals 2. The amplitude is the distance from the midline to the highest value. Or you could say the amplitude is the highest value minus the midline. The amplitude, in this case, is 6. We're going to use this graph of the sinusoidal function f of theta to answer problems 7 through 10. Number 7. Which of the following best describes the behavior of f over the interval from 0 to pi? I've highlighted the interval from 0 to pi, and we can plainly see that f is increasing. Notice how the values are rising from left to right. So we can throw out options C and D, both of which say that f is decreasing. In Unit 1, we learned that wherever f is concave up, the rate of change is increasing, and wherever f is concave down, the rate of change is decreasing. On the interval from 0 to pi, f is concave down, so the rate of change is decreasing. In other words, f is increasing, but at a decreasing rate. So the answer is B. Number 8. Which of the following best describes the behavior of f over the interval from negative 2 pi to negative pi? Here I have highlighted the interval from negative 2 pi to negative pi, and we can see that the graph of f is decreasing. The output values are falling from left to right. We can also see that f is concave up on the interval from negative 2 pi to negative pi. So, putting it together, f is decreasing and concave up. So the answer is C. Number 9. Which of the following best describes the behavior of f over the interval from 2 pi to 3 pi? We are being asked if f is positive or negative, and whether f is increasing or decreasing. I have highlighted the interval from 2 pi to 3 pi. First of all, is f positive or negative on this interval? Well, on this interval, the values are all between negative 1 and negative 3. These are all negative values. All of the values are below the x-axis. So, negative it is. Next, is f increasing or decreasing on this interval? Clearly, f is decreasing. You can see by the way the values are falling from left to right. So, on this interval, f is negative and decreasing. So the answer is D. Number 10. Which of the following best describes the rate of change of f over the interval from negative pi to 0? We are being asked if the rate of change is positive or negative, and we are being asked if the rate of change is increasing or decreasing. Here I have highlighted the interval from negative pi to 0. First, let's decide if the rate of change is positive or negative. One way to answer this is to realize that the rate of change at any point is the slope of the tangent line. So if you pick any point on this interval and draw a tangent line, you will notice that the tangent line has a positive slope. It's an uphill slope. That means that the rate of change is positive. Here's another way to think about it. I've asked you to memorize this chart showing the graphical relationships between f, the rate of change of f, and even the rate of change of the rate of change. To answer this question, we need this part of the chart. The rate of change will be positive wherever f is increasing, and the rate of change will be negative wherever f is decreasing. Since we can easily see that f is increasing on this interval, that means the rate of change is positive. Next, we need to decide whether the rate of change is increasing or decreasing on this interval. The rate of change will be increasing wherever f is concave up, and the rate of change will be decreasing wherever f is concave down. Since f is concave up on this interval, the rate of change is increasing. Putting it all together, the rate of change of f is positive and increasing on the interval from negative pi to 0. So the answer is A. Let's use the graph of sinusoidal function g of theta to answer problems 11 through 14. Number 11. Which of the following best describes the behavior of g over the interval from 0 to pi over 2? Is g positive or negative? And is g increasing or decreasing? Here I've highlighted the interval from 0 to pi over 2. First of all, is g of theta positive or negative on this interval? Well, all of the values are below the x-axis on this interval. All of the values are negative. Next, is g of theta increasing or decreasing on this interval? From left to right, the values are rising. So, g of theta is increasing. Putting it all together, g of theta is negative and increasing on this interval. So the answer is C. Number 12. Which of the following best describes the behavior of g over the interval from pi over 2 to pi? Is g increasing or decreasing? And is the rate of change of g increasing or decreasing? I've highlighted the interval from pi over 2 to pi. First of all, is g of theta increasing or decreasing? It's clearly increasing. You can see that the values are rising from left to right. So g of theta is increasing on this interval. Next, is the rate of change increasing or decreasing? Well, we have learned that that depends on the concavity. The fact that g of theta is concave down on this interval tells us that the rate of change is decreasing. So putting it together, g of theta is increasing at a decreasing rate of change. So the answer is B. Number 13. Which of the following best describes the rate of change of g over the interval from pi to 3 pi over 2? Is the rate of change of g positive or negative? And is the rate of change of g increasing or decreasing? I have highlighted the interval from pi to 3 pi over 2. Let's first decide if the rate of change is positive or negative. There's two ways to think about it. First, you can understand that the rate of change is the slope of the tangent line at any point. If you draw a tangent line at any point on this interval, you will see that the tangent line has a negative slope. Therefore, the rate of change is negative. That's one way to think about it. Or you can go by the chart, which you have hopefully memorized. The rate of change will be positive if g is increasing, and negative if g is decreasing. G is clearly decreasing on this interval, so the rate of change is negative. Next, we must decide if the rate of change is increasing or decreasing on this interval. But we have learned that the rate of change will be increasing if g is concave up, and decreasing if g is concave down. Since g is concave down on this interval, the rate of change is decreasing. Putting it all together, the rate of change is negative and decreasing on this interval. So the answer is D. Number 14. Which of the following best describes the behavior of g over the interval from 3 pi over 2 to 2 pi? Is g increasing or decreasing? And is g concave up or concave down? I've highlighted the interval from 3 pi over 2 to 2 pi. First of all, is g increasing or decreasing on this interval? G is clearly decreasing. We can see that the values are falling from left to right. So decreasing. Next, is g concave up or concave down on this interval? G is clearly concave up on this interval. Putting it together, g is decreasing and concave up on the interval from 3 pi over 2 to 2 pi. So the answer is C. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.